Okay, so this is a good question. I love this question. It's about entropy. Remember that the definition of entropy is that entropy is proportional to the number of ways to distribute energy in a system. So each time there's a different way to distribute energy, we call that a microstate. And so the more microstates, the more entropy there is. So in other words, back to Jump Street, the more ways to distribute energy, the more ways to arrange particles, the more entropy there is. And so this question is really just getting at what are all the different ways to arrange these two particles in a 6-position universe. And so it helps you to get some understanding about, why is it that two particles are more entropic than one particle, why the larger degrees of freedom, in other words, a larger universe would have more entropy than a smaller one. And so what I've done is I went ahead and I created the, it's gonna end up being 15. There's gonna be 15 total microstates. You could do that. You could do a calculation. You could say it's 6 factorial over 4 factorial. You can research that a little bit more if you want to. But certainly a trial and error approach will get you all the different possible arrangements. So let's take a look at these two particles. Now we're going to say the particles are the same. If they weren't the same, then we could do it. We could say, all right, if they weren't the same, then there'd be twice as many ways, because if you swap the positions, even if they're both in the top most boxes, swapping positions would be different. So that we would say there's more than one way, but we're going to have the same two particles. So let's take a look. You can have let's take a look at all the positions where the two particles are right next to each other. So those two, and those two, but then they could also be next to each other like that, or like that, or like that, or like that. Okay, so I think that takes care of all the different positions where the particles can be next to each other. Let's take a look at the particles where they're diagonal, where they're sort of on a diagonal. So, or where there's a space, where there's a space in between them. And so there's a very limited number of options for when there's a space in between them. There can be that one or that one. That's the only way to get a space in between them. Now let's go back and look at those diagonals. So you can have diagonal that looks like that, the reverse that looks like that. We can move it down the box that looks like that, and then have that reverse look down the box. Then we can combine one spot away plus a diagonal. That's that and that. And those are the only possible positions. So if you think about it, there's 15 total states. Now, let's take a look. Those two particles, why is two particles have more entropy than one particle? Well, if I'm dealing with one particle, then the only possible locations for that one particle are in each one of the boxes. That's it. There's only 6 locations. So less number of microstates means less entropy. More number of microstates means more entropy. So this kind of helps kind of explain that. And hopefully you got a feel for what's going on with some of the basics around entropy. Okay, that's that.